All right, welcome back to section 5.2, part 2. And we're starting where we picked up, which is using the table. Now, this table is available in your textbook or e-text, but I'm just going to show you how it works. But in general, we can skip it because we're going to use Excel, and we can get a lot more information out of Excel than we can the table. But this is how the table works. First, you locate your n. So your n is right over here. And then once you have your n, you locate your x, right? So already you're like, uh-oh, it only goes to 8 trials and the x's only go so high. So it's not already, it's not so great. But so you locate n and x. And then let's say you're looking at your n is 5 and your x is 3. Then you go up here and find your p. So let's say your p is 0.5. You would kind of come across, come down, and boom, you would get your probability. So again, you're using the n, the p, and the x. You can use your calculator to do the n, the p, and the x as well. So let's go back to our Twitter example. Given that there is a 0.85 probability, why can't we use the table when 5 adults are selected that exactly 3 know? So we know that our n is 5. We know that our x is 3. And when we try to find 0.85, we don't really find it. It's going to be halfway between here. And technically, that could work. So we're looking at halfway between these two p-values, right? That's 0.8 and 0.9. And if we add them up, so let's add them up. Grab my calculator. So 0.205 plus 0.073. And divide by 2, and it does work, 0.139. That is the answer, right? We have the other answer right there. But in general, we don't have every p-value or everything like that. So we can use the table, but maybe that's not the best route. Let's look at another example with the table. All right, so we have a Harris poll that says 60% of adults believe in the devil. Assuming that we randomly select 5 adults, use table A1 to find the following. The probability that exactly 3 of the 5 believe in the devil, and that the probability of adults who believe in the devil is at least 2. Right? So this is where the table might be helpful over the calculator, but we'll see that Excel in general is better. So find the probability that exactly 3 of the 5 believe in the devil. All right. So exactly 3. So our n is 5. We're still looking at 5 adults, 3 successes. And our p is 60%, which we know is 0.60. So we're looking here. Okay, so we're going across. We're coming down, and right here. So we get 0.346. That was pretty easy, right? That's okay. If the information is in the table, it's certainly not a bad option. The probability that the number of adults who believe in the devil is at least 2. All right, so this is the probability that it's at least 2. So maybe you would, another way to look at this is that x equals 3, right? So there's different ways to communicate the probability. Well, if x is greater than or equal to 2, that's the same that probability of 2 or the probability of 3 or 4 or 5, because we're going up to 5 people, or's are addition. So we need all of these probabilities now. Now, we could certainly use the calculator, right? But the calculator just gives us one at a time. So this is why maybe the table could be considered better, because you can find all of these probabilities in one spot. So our n is still 5, but our x is no longer 3. We're looking at x is 2, x is 3, x is 4, or x is 5. And we're still coming down here. So we're looking at, let me use my highlighter. We're looking at these sections here. And so here we go, right? So this is 0.23 plus 0.346 plus 0.259 plus 0.078. So when we add up all those, the probability that at least 2 adults believe in the devil would be 0.913. So you could certainly type in your calculator the NPX for each of those x values, right? So you would have to go through here and do the NPX. So the n would be 5. This is 0.60 now. And we would have to start with 2. and that's 0.230. And then we would just repeat the process again. Now we want to know for 3. And then, we're getting the same answers, and you could keep doing that too, and that's totally fine. So go ahead, and they want you to, I would like you to use the table here to see what it's like to use the table. So again, exactly 7, at least 4, fewer than. So I'm just going to remind you here, greater than or equal to, less than, and no more than is less than or equal to. And there are the solutions. So the final way is with Excel. All right, so you can follow these directions exactly or take a peek here. What we need to do is you can either type in equal binom.dist, that's important, and then you'll type in your x, or you can type in your values over here, the n and the p, and then this is always going to be a 0 at the end, so just don't forget that. So let's do a couple of examples. So inside of Excel, which will kind of do some crazy things right here, but what we're going to do is we are going to type in binom, and you can see this .dist right here. And normally when you type it, it should just like click enter. So the number S is what we want here, or our, the number of successes is what that means. So we want 3 adults, 5 trials, and the probability is 0.85, and we're always going to put a 0 at the end. And if you're using Google Sheets, it's not going to prompt you like that, so you will need to remember that it's XNP0, and then you hit enter, and voila, you get your answer there. So the probability is exactly 0.138 or 139. So now let's do the Harris poll example where we had to use the table for a bunch of different problems. So in this particular problem, I'm actually going to label my X, and then these are going to be the probabilities. That's just going to help me out here. So because we have to deal with so many different things, we've got all the way to 5, but we need to know at least 2, which means we need 2, 3, 4, 5. So the probability here is the binom dist, and remember that yours should pop up, and then I think it's just because of the application that I'm using. So then in this case, I'm just going to say, well, I know that the success is actually going to have to do with that X value, right? Because I want to know all the different X values. It's always going to be 5, and the probability is 0.60, and it's 0. And I can drag it down here to get the rest of these. And that, if you want to double check, that's going to be for 1 success. And then here is going to be for 2 successes. And it kind of just does it for you here. Oop, don't do what I just did. Okay, just making sure. So now exactly 3 of the 5 adults, there's our probability right there. So the probability that X equals 3 is right here. Now, the fun thing is we want to know the probability that X is greater than or equal to 2. You're not going to have to type any of that in. I'm just showing you because I've got my keyboard out. So what this is equal to is it's actually equal to this probability plus this probability plus this probability plus this probability, and we get 0.913. So instead of having to use the table, we can use Excel. So go ahead and do this and try using Excel. You can use Google Sheets as well to see if you can calculate. You've already done all these, but see how it feels using actual spreadsheets. And there are the solutions. I went ahead and added my N and P over there, and you can see. There you go. So let's talk about mean and standard deviation. There are formulas for binomial distributions. We need the N, the P, or the N, the P, and the Q. And again, significantly low values are 2 standard deviations below or 2 standard deviations above. So our last example will be this one here. So between these years, there were 460 NFL games decided in overtime, and 252 of them were won by the team that won the coin toss. Determine N, P, and Q. Assume that winning the overtime coin toss doesn't provide an advantage, so it's equally likely. So N, how many total trials are we dealing with here? 460. P, what's the probability of winning a coin toss? 0.5. Q, what's the probability of losing a coin toss? 0.5. So find the mean, the standard deviation, and for these. So the mean, if you go back, let's just flip back here. The mean is N times P. So our mean is 460 times 0.5, which is 230. And to get our standard deviation, that's going to be the square root of N times P times Q. And again, I just got that from our formulas over here. So that's the square root of 460 times 0.5 times 0.5. And when you type that into your calculator, you should end up getting the square root of 115, which is 10.72. So use the range rule of thumb to find the value separating the number of wins that are significantly low and high. So remember that significantly low is anything that is less than 2 standard deviations below the mean. And significantly high is anything that is 2 standard deviations above. So we need to calculate these. So what is mu 230 minus 2 times the standard deviation 10.27? And here it's 230 plus 2 times 10.27. So we get, when we type that in, 208.56 in this way, and then 251.44. So these are the significantly high and low values. So is the result of 252 overtime wins significantly high? It falls just above here, so the answer is yes, it is significantly high. So you go ahead and give these a try. And that concludes section 5.2.